Hey, what's up everyone? I welcome you to the channel. So there were some questions that were buzzing in my comment section once again, and this time the questions are on infiltration, just as you can see the whiteboard. So we will be discussing in this video these questions, few of the questions which I think are much important to be discussed on this platform, and I couldn't get all the questions. I'm really sorry for that because there were few subjective questions which are really very big, for which I will be making a separate video. Till then, the few short questions which needed to be discussed are very conceptual questions, and this will be discussed in this video. So without further ado, I'll be starting this video, and if you are new to this channel, please do not forget to subscribe the channel and also press the bell icon so that you don't miss any notifications. So let's start the video. So let's pick up the first question for the day. In the first question, it says that if the rainfall intensity is higher than the infiltration rate, the infiltration will be equal to. So in this question, it is asking that there was some amount of rainfall which is much higher than the infiltration rate, and then it is asking then what would be the infiltration that will be actually occurring in that particular place or that particular soil sample, whatever it might be. So the four options that are given to us is the interflow, the ponding depth, the rainfall intensity, and the potential infiltration. So let me tell you one thing which we have discussed in the theory of infiltration also, that suppose I am making this graph, and let us say that this is the maximum amount of infiltration that can take place in that particular soil sample or that particular ground or the surface that is over which the rainfall is occurring. So let us suppose in the first hour we have this much amount of rainfall, in the second hour we have this much amount of rainfall, in the third hour we have this much amount of rainfall, in the fourth hour let us say this is the rainfall that is happening. Okay, so this might be continuing till the whole storm duration, but one interesting thing I would like you to notice that if suppose this is the infiltration rate, the maximum infiltration that will be occurring is this much only. In no way this much, suppose these bar graphs are very high, in no way that will be occurring that this much of rainfall will be contributing to the infiltration. So basically what happens, if this is the maximum infiltration that can occur, so even if the rainfall is higher, so this much will be the infiltration that will be occurring. So as a result, this much, the excess rainfall, you can say ER or rainfall excess, whatever you want to say, this will be contributing to the surface runoff. So in our options we were given interflow, ponding depth, rainfall intensity, and the potential infiltration. So let us read. If the intensity of rainfall is more than the infiltration capacity, then the infiltration rate will be equal to the infiltration capacity, and rest of the amount of rainfall will be in the form of runoff. That's what I have explained you right now. Now we have an interesting option, that is the fourth option, that is the potential infiltration. So what is potential infiltration? This potential infiltration is nothing but your infiltration capacity only. The infiltration capacity has the other name known as the potential infiltration. So which is basically the maximum rate at which the soil can absorb water. So the potential infiltration is same as that as the maximum infiltration capacity. Okay, so in this question our correct answer is option 4. Option 4 is our correct answer. Okay, now let's move on to the next question. In the next question we have the infiltration measured using the double ring infiltrometer is more accurate than that of from the single ring infiltrometer because, and the four options are: lateral spreading of infiltrated water will not be there, lateral spreading of infiltrated water will be only there at the outer ring, no lateral spreading of water will be there, and less macro pores. So let me tell you one thing. The purpose of the double ring infiltrometer was there so as to accomplish or to compromise the disadvantage the single ring infiltrometer had. The single ring infiltrometer had this problem that there was much amount of lateral flow of water. That is, suppose this is the ring, when the water was added inside the ring, some amount of water always went outside the ring, so which is known as our lateral movement. So basically, the outer ring of the double ring infiltrometer reduces the lateral movement from the inner ring and thus gives a more accurate value for the infiltration rate. So now just think what could be our answer. So we have the options like lateral spreading of infiltrated water will not be there, lateral spreading of infiltrated water will be only there at the outer ring, and no lateral spreading of water will be there, and or is it less macropores. So we can omit the option number 4. We need not to consider what would be the macropores that is available to us. You cannot say that no lateral spreading of water will be there, or first and the third options are quite similar, that lateral spreading of water will not be there or no lateral spreading of water will be there. You cannot say that there won't be any lateral spreading. Yeah, there will be some lateral spreading, but that lateral spreading of infiltrated water will be only there at the outer ring. So correct option is option 2. Our correct option is option 2. Okay. So the next question is, according to the Kostiakov's infiltration equation, the infiltration rate is infinite at t is equal to 0 and approaches infinity for long times, or is it infiltration rate equal to infinite for long times and 0 for t is equal to 0, or is it infiltration rate equal to hydraulic conductivity for long times, or is it infiltration rate equals hydraulic conductivity for all times? So let me tell you, according to the Kostiakov's infiltration equation, our infiltration is equal to, that is y is equal to a times t raised to some power b. Okay, where a and b are some constants, t is the time and y is the infiltration that is taking place. Now just tell me one thing, if t is equal to 0, what will happen? Of course, if t is equal to 0, then this term becomes 0 and we can say that y will be equal to 0 at t is equal to 0. On the contrary, if we have certain values of t and we keep on increasing the value of t, so we can say that the y will have some increasing values when we are increasing the value of t. So what we can say that in our question, according to the Kostiakov's equation, the infiltration rate is infinite at t is equal to 0. No, it's not right that, and approaches infinity for longer times. So we can omit option 1 because it is contradicting of what we just saw in this case. So if we see the third and the fourth option, they are asking about a term which is known as the hydraulic conductivity, and you saw that in this particular equation we don't have any hydraulic conductivity. It directly depends upon two constants, a and b, and the time taken. So we can also omit option 3 and 4. So we are left out with option 2, which is actually our correct answer, which says that the infiltration rate equals to infinite for long times and 0 for t is equal to 0. Is it not right that whenever this T is 0, we have our infiltration equal to 0, and as we keep on increasing, because it has some power, our infiltration will also be increasing, and at a very huge or a long time the infiltration will become infinite. So our correct option is option 2. Sorry, option 2 is our correct option. Okay, moving on. This is our next question. In this question we have, in the relatively dry state of soil, only absorbed water exists in the soil because of, the options are the capillary force, the gravity force, the electrostatic force, the friction force. So it is asking that whenever we have a soil of a much drier state, there will be some water which will be in the form of adsorbed water. We can say that there will be some adsorbed water will be there, and this exists because of which of the following results? Is it the capillary force, or is it the gravity force, or is it the electrostatic force, or is it the frictional force? So now let me tell you, any kind of adsorbed water, if it is present in the soil, it is mostly because of the electrostatic force. So let us see the hint that we have, that is the region of the adsorbed water in soil, that is the water which is bound to soil particles as a result of the attraction between electrical charges on their surface and the water molecules. So this is the water that is absorbed in the soil. So it is water which is bound to the soil particles, which is due to the electrical charges on the surface of and the water molecules. So the only option that we have is the electrostatic force, that is the option 3, which is our correct answer. In the next question, very sharp discontinuity between the wet soil and dry soil beneath the ground surface during the process of infiltration is known as. So there will be some discontinuity between the wet soil and the dry soil, which can be easily mapped, where until which point we do have the wet soil and until which point do we have the dry soil. It can be mapped quite easily by seeing the complexion of that particular soil sample. And what is it known as? The very sharp discontinuity between the wet soil and the dry soil. So there will be some point where there will be a sharp discontinuity between that wet soil and the dry soil, and that too occurs during the process of infiltration only, and it is known as what? We have 4 options again. It is the moisture profile, the wetting front, the capillary fringe, or is it the transmission zone? So let us read the hint. The region of rapid change in color resulting from an increased water content is called the wetting front. So we are seeing a term that is the rapid change in color. So regarding color, if I am talking about some color, let us now just move to some different topic. Maybe it would be little bit cumbersome for the students who are not much from the remote sensing background. But in our remote sensing, we have certain things like, suppose there is some, let me explain you nicely. There is some surface which you want to delineate. What is it? Whether is it a water source, or whether is it a soil, or whether is it a vegetation. That can be done with the help of remote sensing. And it is detected well that the water has a lesser reflectance as compared to the soil, which further has lesser reflectance as compared to the vegetation. So in other words, you can say that a presence of water in a little bit presence of water in the soil sample will somehow decrease the reflectance because the water has a lesser reflectance as compared to the soil, right? So in general, we do have like a dry soil or a barren soil, like what we have in the deserts, has more reflectance than the wet soil. So this color coding, and not necessarily color coding, or even you can actually see the soil samples and you can discriminate whether there it is a wet soil and a dry soil. Wet soil will be somehow darker and dry soil will be somehow lighter. So the difference, certain discontinuity will be observed in the place known as the wetting front, as we read in this description that the region of rapid change in color resulting from an increased water content is called the wetting front. Let's read the next question. Next question is regarding the Phillips equation, which is very important for our infiltration. It's one kind of infiltration equation, and according to the Phillips equation, during infiltration, so we have four different options which we have to choose. That is, firstly, is the sorptivity term predominant, or the hydraulic conductivity term predominant, or the initially sorptivity term will be predominant and for long times hydraulic conductivity term will be predominant, or is it the initially hydraulic conductivity term will be predominant and for long times sorptivity term will be predominant. So you can see in the Phillips equation we have two important terms known as the one is the sorptivity and the other one is the hydraulic conductivity. So let us see how does the Phillips equation actually look like. You can see over here, this is the Phillips equation. The one in the box is the Phillips equation. It says that Fp, that is the infiltration, is equal to half of St to the power minus 1 by 2 plus K. So we have Fp is equal to half of St to the power minus 2 plus K. Half of St to the power minus half plus K. So just tell me one thing, initially at t is equal to 0, at t is equal to 0, this term will be equal to 0. Am I correct? Yeah, I am correct, because at time t is equal to 0, this term will be 0. So we will be remaining with Fp is equal to K. That is, our K is the, oh sorry, let me tell you one thing, our K is the hydraulic conductivity and S is the sorptivity. Sorptivity is denoted by S and the hydraulic conductivity is denoted by K. So at time t is equal to 0, the infiltration will be equal to K, and as and when our time increases, our this term will be predominant. So we can say that initially the hydraulic conductivity term will be predominant, because at time t is equal to 0, the factor which had the sorptivity term will be diminishing, because of will be vanished actually, because it has t at the initial phase, the time t will be equal to 0, and hence that factor will become 0 and Fp will be equal to K. And therefore for the longer times, when we will have a good amount of time t, then that factor will be very much predominant as compared to that of the hydraulic conductivity. So we can say that initially the hydraulic conductivity term will be predominant, and for longer times sorptivity term will be predominant. Option 4 is our correct answer for this particular question. The next question says that the flow of water in an unsaturated medium is caused due to, and the options are datum head and velocity head, velocity gradient, suction head and datum head, or is it the gravity head? Just remember one thing, whenever there will be some flow of water, there has to be some head difference, right? There has to be some head difference, and also there will be some velocity head difference also. There will be some datum head difference, and also there will be some velocity head difference. So in this particular question, we should go with the first option, that there will be some datum head and a velocity head of one side, and then in the other side we don't have that much of head, and then we will be seeing some flow of water. And this is our last question for this particular video. This is the flow towards the stream from the unsaturated zone beneath the ground is termed as, the options are the interflow, the base flow, the stream flow, or the runoff. So the water that will be traveling from the unsaturated zone in the ground to the streams is known as the interflow, whereas the base flow is the minimum amount of water that is always present in a stream, irrespective of whatever the season or whatever the inflows we are having or whatever storm we are having. That base flow will always be constant, that is present in the streams. The stream flow is the total amount of flow that is occurring in a stream, or the runoff, that is the excess rainfall, or that is the extra amount of rainfall apart from the infiltration that will be traveling from the surface to the streams. So basically it is the interflow, that is where the water flows towards the stream from the unsaturated zone beneath the ground. So our correct option is interflow. Even if we read the hint that I have given over here, that is interflow is the lateral movement of water in the unsaturated zone or the vadose zone. So if you don't know about the vadose zone, you can simply Google about it. You will get the information what is vadose zone, what is unsaturated zone, and there will be another zone that is known as the saturated zone. So comment down below, what do you get about the unsaturated zone, the vadose zone, and the saturated zone. And so with this question we come to the end of this video. There were some few more questions but time is really a big constraint for me at this stage, so I could just come up with this many questions only. There are actually few more 2 or 3 subjective questions that were asked in the comment section. So if you really want those questions to be solved, I'm really sorry, because of the time constraint I cannot make the video of those questions. Those questions really do have a long solutions. For that, the solution is, I have posted my email in the description. You can mail me those questions and then I'll be solving them and will reply you within some due time. So that's the end of today's video. I hope you will like this video. So please put a like, that will be giving me some motivations, and also put some more questions in the comment section if you want more of these Q&A videos. So thank you and have a good day. Please do not forget to subscribe the channel if you are new, and also share and recommend this channel for the friends who are from civil engineering and water resource engineering background. Thank you and have a good day.